Pleasant day everyone, we are the Group 3 and we will be discussing about Adams' method. Adams' method of apportionment proposed by John Quincy Adams in 1832 is a divisor method designed to allocate legislative seats proportionally based on population. In the early 19th century, the United States faced challenges in fairly distributing seats in the House of Representatives among states with varying populations. Adams' method operates as a divisor method with rounding up, ensuring that any fractional quota, regardless of size, is rounded to the next whole number. This approach contrasts with Jefferson's method, which always rounds down. By consistently rounding up, Adams' method aimed to prevent underrepresentation of smaller states, promoting a more equitable distribution of seats.
What is Adams' method? So Adams' method is a modified divisor method that is used to distribute seats in the legislature or representative body among states, regions, or parties based on their populations or vote shares. So Adams' method was proposed by John Quincy Adams in the 19th century. Adams' method is similar to Jefferson's method but differs on how quotas are rounded in what way. Adams' method quotas are rounded up while Jefferson's quotas are rounded down. Wanna learn more? Stay tuned.
Adams' method of apportionment is a mathematical method used to allocate seats or resources, such as votes, representatives, or funding, to different groups or regions based on population and other criteria. The process ensures that the allocation is as fair as possible while adhering to certain constraints. Now here are the definition of terms. Quota, the ideal or proportional number of seats or resources each group should receive, based on their share of the total population or sources. Lower quota, the greatest whole number that is less than or equal to the quota for each group. Groups are assigned this amount initially. Upper quota, the smallest whole number that is greater than or equal to the quota for each group. This is often used as a guideline for distributing any remaining seats or resources. Surplus, the remaining seats or resources that have not been allocated after the lower quota has been assigned. Apportionment, the actual distribution of seats or resources among the groups, ensuring that each group receives a number close to its quota. Adams' method is particularly used in contexts like legislative seat apportionment, where it's important to distribute resources or seats in a manner that reflects the relative sizes of different groups.
So, let's talk about the Jefferson's method and Adams' method. So Jefferson's method and Adams' method are both apportionment method used to allocate the seats. Example in a legislature. So, proportionally among different districts based on their populations, they are both divisors method, meaning they use a divisor to determine the number of seats each district receives. However, they differ in how they determine that divisor. So, let's start with the Jefferson's method. In Jefferson's method, it also called as a method of a greatest divisor. So, Jefferson's method is a greatest. It has a 4-step. First step is to calculate the standard divisor. So, divide the total population by the total number of seats to be allocated. Second, calculate the quotas. Divide each district population by the standard divisor. So this gives the initial non-integer number of seats each district should receive. Third is determine the modified divisor. So if the sum of the integer parts of the quotas doesn't equal the total number of seats of a modified divisor is used, this divisor is smaller than the standard divisor. So the modified divisor is found through trial and error. typically starting slightly below the standard divisor and iteratively adjusting until the sum of the integer parts of the quotas using the modified divisor is equal to the total number of seats. The last step is allocate the seats. Divide each district population by the modified divisor and round down to the nearest whole number, so this is the final allocation of the seat. Next is the Adams method. The Adams method is a method of a smallest divisor, so it has the same steps of the Jefferson's method. First is calculate the standard divisor, as what I said, same as Jefferson's method. Second, calculate the quotas, same as Jefferson's method again. Third is determine the modified divisor. So similar to Jefferson's method, a modified divisor is needed if the sum of the integer parts of the quotas doesn't equal the total number of seats. However, in Adams' method, the modified divisor is larger than the standard divisor. So again, trial and error is used starting slightly above the standard divisor. So fourth is the allocate seats. Divide each district population by the modified divisor and round up to the nearest whole number. So this is the final allocation of seats. So the key difference lies in the direction of adjustment of the divisor and the rounding method used in a final allocation step. Jefferson's method favors larger states, round down, uses a smaller divisor, while Adams' method favors smaller states, rounds up, uses a larger divisor. So, example. Imagine you have a 100 seats in a parliament and several states with different population. Both Jefferson's and other methods try to fairly divide those seats based on the population. So, in Jefferson's method, it has a fair share and adjust down. First is figure out how many seats each state should get based on its population, so this might be a decimal. Second is if the total number of seats isn't exactly 100, Jefferson's method lowers the fair share number slightly until the total number of seats add up to exactly 100. Then each state gets the whole number of seats below their adjusted fair share. Larger states benefit slightly. While the Adams method, it also has a fair share and adjusts up. So, in a fair share, same as Jefferson's, calculate the initial fair share of seats for each state. While in adjust up, if the total isn't 100, Adams' method raises the fair share number until the total is exactly 100. Then each state gets the whole number of seats at or above their adjusted fair share. Smaller states benefit slightly. In short, Jefferson's rounds down and favor larger states, while in Adams rounds up and favors the smaller states. Both use a bit of trial and error to find the right adjustment to get the exact number of all the seats.
So I'll be giving a sample problem about Adams' apportionment method. Again, Adams' apportionment method is when congressional seats are apportioned. The upper quota Q for each state is calculated by dividing the state population by the standard divisor S and rounding up. Using Adams' method, S is changed until the sum of the upper quotas matches the number of seats. For example, suppose a parliament of 10 people is to be elected to represent 4 states, with A having 8,000, B 9,000, C 24,000, and D 59,000 people. The standard divisor S is the total population over total seats, which is 100,000 over 10, and that is equals to 10,000. And the population of S of A, B, C, D is 0.8, 0.9, 2.4, and 5.9. With their quota 1136 and their surplus seats with this value of S 11 seats are assigned, so we need the value of S to be larger to assign only 10 seats.
For Adams' method solutions method, step 1 is to find a suitable divisor D. Step 2 is using D as the divisor, calculating each state's modified coda. Step 3 is each state is apportion its modified upper coda, round up to the next whole number. Step 4 is to adjust the divisor if needed. If total exceeds the required number, increase the divisor. If total accumulates few, then decrease the divisor.
In conclusion, the Adams method is an effective apportionment technique that ensures proportional representation by dividing populations by a chosen divisor and allocating seats based on the results. By adjusting the divisor, the methods aim to fairly distribute seats while maintaining proportionality. These methods play a significant role in systems where accurate and equitable representation is crucial.